Good morning. Okay, so for chemistry class, okay, we're now in chapter 7, covalent and metallic bonding. Right, so basically there are three subtopics. Okay, the first one, okay, which is will be learned today, okay, covalent bond sharing electrons. Okay, and then followed by structure and properties of covalent substance. Okay, and the last one will be the metallic bond. Okay, let's see the first one. Okay, so the learning outcomes, okay, by the end of this section, you should be able to describe the formation of a covalent bond, okay, by the sharing of electrons. Okay, the keywords here, okay. Describe the formation of covalent bonds between non-metallic elements, okay, using dot and cross diagrams. Okay, and the last one, the arrangement of electrons in covalent molecules. Okay, right, so what is a covalent bond? Covalent bonds are formed between atoms of non-metal. Okay, please take notes on the highlighted words. Okay, non-metals. Okay, only happens in non-metals group. Okay, right. Sorry. Okay, non-metal groups, for example, like chlorine. Okay, chlorine, bromine, okay, iodine. All of them are non-metal. Okay, so valence electrons. Okay, valence, which means the last, okay, or outermost electrons. Okay, the last one electrons, okay, are shared between two atoms. Okay, so the definition for covalent bond, okay, the covalent bond is a bond formed by the sharing of electrons between two atoms, right? So please memorize this. Okay, so each atom in the molecule achieves the stable electronic configurations of a normal gas. Okay, as you know, normal gas, for example, like, okay, you have the xenon, neon, argon, krypton, helium. Okay, all of them are normal gas. Okay, so they are the stable. Okay, so all of the element, okay, in your periodic table, okay, they tend to achieve the stable. Okay, so that's why they always say noble gas. Okay, stable electronic configuration of a noble gas, because noble gas is the only element that stable, right? Okay, so formation of a molecule. Okay, covalent bonds can be formed between atoms of the same element, for example, like chlorine and chlorine. Okay, atoms of different elements. Okay, for example, like water. Okay, water is different elements. Okay, so below here it gives you the example. Okay, so what is a molecule? Okay, you know that a molecule is formed when a group of two or more atoms are held together by covalent bonds. Right, so this is the definition for molecule. Okay, so let's see the examples of molecules of elements, which is the atoms of the same element. Here you have the hydrogen, okay, H2, okay, oxygen, O2, chlorine, Cl2. Okay, atoms of different elements, example like, okay, example of molecules of a compounds, for example like water, H2O, methane, CH4, carbon dioxide, CO2, ammonia, and H3. Okay, please take note that all of them are non-metal. Okay, H is hydrogen, O is oxygen, methane, C is carbon, H is hydrogen, okay, C is carbon, O is oxygen, N is nitrogen, H is hydrogen. Okay, all of them are non-metals. Okay, let's see example here. Okay, so example hydrogen, H2, so you have two atoms of hydrogen. Okay, here is dot, this one is cross. So each hydrogen atom, okay, has one electron in its outer shell. Okay, which means that they are unstable. So in order to make them become stable, okay, they have to share their electrons. Okay, by sharing electrons, each atom has two electrons in its outer shell. Okay, this is how the diagram should be look like. Okay, let's say there are two of them are overlapped. Okay, and the middle here shows that this is the sharing electrons. Okay, you have the dot which is coming from the here, cross which coming to from this one hydrogen atom. So they both combine together, they will become stable. Okay, so at the end is here is say each hydrogen atom has gained a stable duplet configuration. Duplet, which means two. Okay, so they have the two. Okay, at the last electron, okay, they have two electrons, which is stable. Okay, we call that as a duplet. Okay, for example, like this. Okay, Dot and cross diagram. So when the question asks you to draw the dot and cross diagram, this is how you should draw. Okay, you can either draw like this or like this. Okay, structural formula like this, molecular formula H2, model like this. Okay, you have to know the difference. Okay, so this line, this one, okay, this line represents a single covalent bond. This one, okay, this line, okay, this one, okay, not this one, okay, this is the line. Okay, represents a single covalent bond. Okay, so the sharing of two electrons result in the formation of a single covalent bond. Okay, chlorine Cl2. Okay, so each chlorine atom has 7 outer electrons. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, so this is between same element. Okay, this chlorine and chlorine. Okay, dot and cross. Okay, in order for them to become stable, so they have to share. Okay, remember that covalent bond only happen in non-metal groups. Okay, don't confuse with ionic bonding. Okay, ionic bonding is between metals and non-metals, but covalent bond is non-metal and non-metal. Okay, so the two chlorine atoms combine to share a pair of electrons. So at the end of this, okay, each chlorine atom has obtained an octet. Octet, which means outermost shell has a 8 electron. Okay, outermost, outermost, which means the last circle. Okay, octet, which means 8 electron. 1, 2, 3, 4, 5, 6, 7, 8. Okay, configuration. Okay, not dot and cross diagram sometimes only show outer shell electrons. Okay, this is the outer shell, the last one. Okay, again, dot and cross diagram for Cl, chlorine. Okay, structural formula, molecular formula, and model. Okay, as in the hydrogen molecule, a covalent bond, okay, is formed by sharing one pair of electrons. Okay, oxygen atoms, okay, this is also the same. Each oxygen atom has 6 outer electrons, needs 2 more electrons to form a stable octet configurations. So they have 4 here, 1, 2, 3, 4. 2 coming from here, 2 coming from here. So therefore you have 4 here. Here they are overlap, okay, which means they are sharing. So at the end you can say the two oxygen atoms combine to share 2 pairs of electrons. Here each oxygen atom has achieved an octet electronic configuration. Okay, the same one. Okay, dot and cross diagram, structural formula, molecular formula, and model. Okay, this represents a double covalent bond. Okay, whenever you see this, okay, so you have the double covalent bond between the two oxygen atoms, right? So the sharing of 4 electrons results in the formation of a double covalent bond. Okay, for nitrogen it is the same, but here it says each hydrogen atom, the nitrogen atom, has 5 outer electrons, only 5. Okay, in order for them to achieve, there must be 8, right? 8 or either 2. Okay, so needs 3 more electrons to form a stable octet configuration. So since this is between non-metal and non-metal, so they have to share it. So that's why here overlap here in the middle here you have 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, 1, 2, 3, 4, 5, 6. Okay, 7, 8. So they both of them are now stable. Okay, so the two nitrogen atoms combine to share 3 pairs of electrons. Okay, at the end you can say that each nitrogen atom has achieved an octet electronic configuration. Okay, this is the for nitrogen. Okay, N2 dot and cross diagram. Okay, you can either draw it like this or like this. Okay, okay, but make sure you have to put the dot and cross. Okay, structural formula. Okay, now you have triple bond. Okay, this represents a triple covalent bond between the two nitrogen atoms. Okay, so molecular formula model. Okay, so the sharing of 6 electrons result in the formation of triple covalent bond. Okay, so you have 1, 2, 3. Okay, 3 straight line. Okay, how about now we have different elements, which means that you have hydrogens and have oxygen. Okay, for example, like water. Water molecule is formed by 2 hydrogen atoms and 1 oxygen atom. In a water molecule, each hydrogen atom is bonded to the oxygen atom by a single covalent bond, which means that they have to share 1 electron with, okay, 1 electron from hydrogen, each hydrogen atom, and 2 electrons from 1 oxygen atom. 2 single covalent bonds are formed. Okay, 1, 2, 1, 2. Okay, 1 2, okay, 1 2 1 2 3 4 5 6 7 8. Okay, so the oxygen atoms share two outer electrons with two hydrogen atoms. The each hydrogen atoms share its outer electron with the oxygen atom. So the oxygen atom achieves an octet electronic configurations. Okay, each hydrogen atom achieves a duplet electronic configuration. Duplet, which means two. Don't forget that two. Okay, oxygen is 8. Okay, 1 2 3 4 5 6 7 8. Okay, oxygen is only 1 2 1 2. Okay, so okay, I will stop here. Okay, so thank you guys for listening this video.